right. Hey, real quick today, just talking a little bit about gravitational potential energy. We've talked about or around the topic, I guess, but we're actually going to put some formulas to it. You actually do some math behind it here. So it's the energy that an object has due to its position above the ground. And so with that, it depends on three things: the mass of the object. So the more massive the object is, the more energy it's storing. Acceleration due to gravity. If it's on Earth with an acceleration due to gravity of 9.8 meters per second squared, it's going to have more potential energy than if it was on the moon. And then the height above the ground, okay, because we know that the higher an object is, the more time it's going to have to build up speed as it hits the ground there. So using those three things, we're going to determine gravitational potential energy. We're still using joules as our measurement, just like kinetic energy. How we calculate it is a pretty simple one, just mass times the gravitational constant times height. So gravitational constant is 9.8 meters per second squared times the mass times whatever height it is. So if a 2 kilogram object is 5 meters off the ground, calculate its GPE, that would be 2 times 5 is 10 times 9.8, or it'd be 98 joules is what that potential energy of that object would be. So there's a little bit about gravitational potential energy. Like I said, pretty straightforward, just mass times the gravitational constant times height.